All right, let's jump right in. We're going to talk about a kind of number that honestly sounds like something straight out of a fantasy novel. But here's the crazy part. It's actually fundamental to, well, to reality itself. This is our deep dive into complex numbers. Just let that sink in for a moment. The theory that explains, everything from the tiniest little particles to the mind-boggling scale of the universe, that's quantum theory. It's not just some theory, it is our single best, most complete description of reality we've got. And here is the ultimate twist. The mathematical language that this entire theory of reality is built on, it all hinges on a concept that mathematicians literally had to, well, imagine. So how on earth did we get here? So our story doesn't actually start with quantum physics. Nope. It begins with a problem, a crack in the very foundation of the numbers we all use every single day. You know this line. We all learned about it in school. It's simple, it's intuitive, it's just one dimension. You go left for negative, you go right for positive. Seems like it covers everything, doesn't it? Well, as it turns out, not quite. That simple little line has a major limitation. One that just smacks you in the face when you try to solve certain equations that pop up all over science and engineering, like the classic quadratic equation. Okay, so this right here, this pinpoints the exact problem. The formula for these equations involves taking the square root of something called the discriminant. And look, if that discriminant is positive or zero, you're golden. Everything is fine. You get one or two real answers that live happily on our number line. But look at that bottom row. If the discriminant is negative, the math asks us to take the square root of a negative number. And with the numbers we know, that's impossible. Any real number you can think of squared is always positive. It's a mathematical brick wall. Or is it? So when math hits a wall like this, what does it do? It gets creative. It literally imagines a way forward. And this is the giant leap of logic. The whole problem is that no real number can be squared to get a negative. So what if we just invent one? What if we just define a brand new kind of number whose entire job is to solve this one single problem? And here it is. This is the hero of our story. The imaginary unit, I. And its definition is just so beautifully simple. We just declare that I squared is equal to -1. That's it. And with that one elegant little rule, an entire new universe of math is about to explode into existence. Now, by creating I, we haven't just found a clever little trick. We've actually created the fundamental building block for a whole new, much more powerful type of number. I'd like you to meet the complex number. It's got two parts. The A part is just a regular old real number, the kind we already know and love from our number line. Then you have the IB part. That's our new invention. It's a real number B that's being multiplied by our imaginary unit I. And building one is super straightforward, just like you see here. You take a real part from the number line we already know, you add an imaginary part, and you just stick them together. So for example, 3 plus 2i, that's a totally valid complex number. It's really as simple as that. So let's go back to our old nemesis, the quadratic equation. Remember that dead end we hit when the discriminant was negative? Well, look at it now. By using our new friend I, we can basically pull that negative sign right out of the square root. That brick wall, it's gone. Poof! All of a sudden, every single quadratic equation has a solution. We've made the unsolvable solvable. But this new number does so much more than just solve equations. It completely changes our whole picture of what numbers even are. It gives them a brand new geometric dimension. So remember we started here with this simple, flat, one-dimensional line. All of our numbers were just points on this line. But I doesn't live on this line. It's something else entirely. It exists off the line, creating a second axis, a whole new vertical dimension, totally perpendicular to the first. And this is the complex plane. Think of it like a two-dimensional map for numbers. Every single complex number has its own unique address right here. It's not just some abstract formula anymore. It's an actual point in space. And plotting them couldn't be easier. The real part of the number, A, that just tells you how far to go left or right along the horizontal real axis. And the imaginary part, B, that tells you how far to go up or down on the vertical imaginary axis. So the number A plus IB is just the point AB on this plane. Okay, so we started with a math problem and we ended up with this beautiful new geometry. But what does any of this have to do with the real world? Well, as it turns out, just about everything. And this is the truly incredible part. The most fundamental, most accurate description of our entire universe isn't written in the language of real numbers alone. It requires complex numbers. It can't be done without them. This is the mind-bending takeaway. The tool we invented to solve a nagging algebra problem turns out to be the essential language for describing reality itself. Why? Because things in the quantum world, like electrons, aren't just little particles. They have wave-like properties, with both an amplitude and a phase. A single real number just can't hold both of those pieces of information at once. But a complex number, with its two parts, can do it perfectly. The imaginary became essential because reality, at its very core, is more complex than a single number line can describe. And that just leaves us with this one profound question. Is mathematics something we humans invent, or is it something we discover? How can a concept born entirely from our desire for mathematical neatness map so perfectly onto the deepest, most fundamental workings of the physical universe? It's a question that really shows you just how deeply connected our abstract thoughts and our concrete reality can truly be.